So what we're going to look at here is an application problem of a composite figure. So what we're going to work with now is a cylinder and a cone, not cone, a hemisphere on the other side. Okay, so the R is the same for the cylinder and the hemisphere, so we need to note that. The height is this distance here. In this case, the height will be 3 meters, and R is, well, in this case, our life's going to be a little easy. It's just going to be equal to 1. So R is 1, and the height of the cylinder is 3 meters. Okay, so if we want to find the volume of this composite shape, all we have to do is add the cylinder, the volume of the cylinder, plus the volume of that hemisphere. And remember, the formula for the volume of a cylinder was capital B times H plus the hemisphere is 2/3 pi r cubed. Now it's 2/3 because we know the sphere is 4/3. We take half of 4/3. That's going to be 2/3. Okay. So remember, this was the general formula. So that's the general formula for the cylinder and the prism. So it just depends on the base. This base is a circle, so the base is just pi r squared times h plus 2/3 pi r cubed. All right, so we just have to substitute our values in. Pi is 3.14, r is 1 in both cases. H, remember, was 3. Okay, plus, let's use a different color for the second formula. Let's try that color. So it's going to be 2/3, 3.14. That's what pi is. Approximation of pi, that is. And r, just make that 3 a little neater. And 1 cubed. All right, so now all we have to do is plug those values in our calculator. In the book, it wants us to keep them as decimals for our answers. So on a quiz on Friday, we're gonna have to put them in decimals, unfortunately. That's the way the system likes it. So when we do those final calculations, we should get approximately 11.5 meters cubed if we're going to the 10th place there. Okay, so let's find the density of this. So just know that you could be asking for the mass of a object. So, but in this case, let's say we're given the density. All right, so, and density is mass divided by volume. So if we want to find the mass, now you can put this is just like a science application that you might see in your physical science class. But density is the mass divided by volume. And if we wanted to solve this for the mass, we can multiply both sides by V. And we get the mass is the volume times the density. So if we're going to find the mass of that composite figure, say we want to know the mass of the composite figure, and you can put both those formulas we just derived there in your theorem book. Okay, So we're going to do the volume, which we just found, 11.5, and we have to know what the density is. So the density is given to us here. So the density of this figure is given to us as 100 kg, 100 kilograms per meters cubed. So every cubic meter, there's 100 kilograms of material. All right, so we're just going to do 11.5 times 100. And basically all we have to do is move the decimal point over 2 places to the right, or you can use your calculator, either way. But whenever you're dealing with units of tens, hundreds, thousands, millions, we can always move the decimal place over. So the mass of this solid is about 1150 kg. So I just wanted to show you that application problem for science. You'll probably see this kind of problems if you do physics down the road. On the quiz or test, we're really going to focus on the math behind the volume and surface area of the shapes. But math and science are connected. As we always say, math is the language of the universe, and science has to use math to solve its problems. So we just use an application here for mathematics and science. So practice your homework. On Wednesday, we're going to have our review day. If you have any questions, write them down, take notes, watch the videos again, and let me know. Look forward to seeing you on Wednesday.